Hello and welcome to our third episode in building a foundation for elementary arithmetic, where we start at pretty much the very beginning and look at addition and subtraction for small integers. Previously, we looked at the number line model, and we also started the chip model. We will continue the chip model today and focus on subtraction specifically. So let's begin with a little story. Remember that you could be a student just learning this, as we all have at some stage in our lives. Or you could be an educator, a parent, wanting to better understand how to explain these concepts in those early stages where it really matters to build a foundation in a very specific way that doesn't promote confusion. The chip model is one of those options in addition to the number line model. So let's talk about this chip model a little bit more. And let's do our story now. We're in school, we're grade 1 or roughly thereabout. And we have some pieces of candy in our bag as we start the day. Let's say we have 3 pieces of candy at the start of a day. Unfortunately, there is a very mean bully, and they come around and pick on us, unfortunately, and take 2 of our pieces of candy. So they reach into our bag and they remove 2 of the candy bars that we had. Now we have just 1 piece of candy. So this story, very simple and easy to understand, illustrates the concept, the intuitive concept behind subtraction. And in our example, it was the calculation 3 minus 2 equals 1. So we have in our subtraction this takeaway concept. So let's write down the 3 steps in the chip model. The first number indicates my starting amount. How much do I have at the beginning? Then, if I subtract, there's going to be some removal. There's going to be some takeaway action that is happening. And the next number, the next part in this instruction, tells me what to remove. So in the case where I have all positive, both of these are positive integers, and the second one is smaller than the first one, that is certainly the most basic, simplest way of having this subtraction. But because we're dealing with integers, different things could happen. So let's look at some variations for different stories and different examples. Let's reset this. Let's draw our table, and let's tell a story again. I'm not sure why my table is that big. Let's draw a more manageable sized table. It certainly does not have to be that big. All right. So let's suppose let's suppose we again have in our bag 3 pieces of candy. That is what we start the day with. Now, an even meaner bully comes along, and they shout towards me. They're going to take away 4 pieces of candy. Let's just remember the numbers involved and what the bully shouted. So let's write this down. It's going to correspond to 3 minus 4. So we start with 3 pieces of candy. They're coming, and they're going to remove 4 from my bag. Now, I don't want to find out what happens when they reach into my bag and they cannot take 4. So I plan ahead. As they walk towards me, I ask my friend, "Can I please borrow one of your pieces of candy?" My friend is very nice and says, "Sure you can, but you're going to owe me a piece of candy later." So what I've put in my bag is essentially another piece of candy and a little slip saying that I owe my friend. So nothing has really changed in the value of my bag. It's still a value of 3 pieces of candy. I have visually 4 and 1 debt. But now at least I'm prepared, and the bully comes around and removes 4 pieces of candy from my bag. They are gone. The bully walks off, but at least I could accommodate them, and I didn't want to find out what happens if I couldn't. So what do I have left in terms of candy? I have 1 debt that I still need to pay my friend. Luckily, they're not in a hurry, but that is the value of my bag is therefore -1. So let's just review, because the subtraction is still a takeaway concept. However, in this case, even though they were both positive integers, the second number was bigger than the first, and with that comes an extra step. You can think of it sort of as the reverse of the cleanup step, the one we saw before. So I still start with 3 positive chips. Let's just reenact that. Stay in the bag. There we are. 3 positive chips representing the 3 pieces of candy. And again, I'm planning on some removal to occur. Some takeaway will occur. That is what subtraction will always do in this chip model. Then I look at what I need to be able to remove. But I can prepare for it. I can prepare. And before I can actually do it, because if you look at what's on the table or in my bag, I cannot follow the instructions. I cannot complete the instructions, because the instructions require that I physically remove 4 yellow chips, and I cannot do that. So before I can follow the instructions, I need to make a visual, or let's just say an adjustment. I need to adjust what I can see. I need to make an adjustment. In this case, I'm going to include a positive and a negative pair of chips, which corresponds to my friend lending me a piece of their candies. So I have another positive chip and a debt as well, because I cannot change the value of what I had. But that was the preparation so that I can actually complete the instructions of then removing 4 positive chips, leaving me with a value of 1 negative chip. So the chip model makes no assumptions on shortcuts and mathematical equivalent calculations or anything like that. It is building a foundational number sense of how positive and negative integers interact with each other. And this concept of having versus owing is also a very important real-life concept. So the chip model certainly has some benefits. Let's look at another example. We've seen the basics, but the numbers can also be negative integers, of course. Let's suppose I start with -2. Let's visualize it as we go. And what I happen to have in my bag is a debt of 2 pieces of candy. Now, let's suppose this example is continued with the instruction to take away, and I have to take away 1 positive chip. So in order for me to be able to complete this action, this story, I need to prepare, because I do not see any positive chips, let alone be able to remove one. So in order for me to bring in a positive chip, I will also bring in a debt of 1, like I'm borrowing 1 from my friend. Now I can complete the action of removing the positive chip, and so I can see on the table that I have 3 negative chips. So there is some slight variations with the numbers involved being positive or negative integers. Let's wrap this up with one more example and a story as well. Let's clear off the table like so. Let's get our bag and our table ready. And let's tell our last story. Let's suppose I start today with a couple of pieces of candy. Actually, we'll write the instructions as we go. So I start with a 2. I start with 2 pieces of candy, and I'm going to subtract. So the story in this case is, regardless of my current candy situation, the principal has been aware of deals that students make with each other and wagers and bullying and all kinds of things. And they want to help out. So they make the announcement that they're going to come around and remove 1 debt for every student. No questions asked. You tell me where your debt is or with whom, and the principal settles it. Now, my current situation is that I have no debt. I am 2 pieces of candy rich. But the principal's going to come around, and they're willing to forgive 1 debt. I want to take advantage of this situation. So, I tell my friend, can I borrow a piece of candy from you? My friend has no problem with that, because I will simply owe them later. So, my value in candy does not change. I have another piece I can see, but I also have a little debt slip that I can't just disappear. It can't disappear. So, at least now I'm ready for when the principal comes around. The principal asks, do you have any debt? And well, I happen to have 1 right here. The principal will remove that 1 debt, and no questions asked, it will disappear. It's gone. It's gone forever. So now, my value is just changed to 3 pieces of candy. And again, the chip model does not change. It simply has different stories depending on where positive and negative integers occur in this equation, in this calculation, in this set of instructions. So let's just act that one out again, just to be sure. I start with 2 pieces of candy, 2 positive chips, and notice how we're following the instructions in the same way as all the others. But we have to pay attention to which ones are positive chips and which ones are negative chips. So the subtraction tells me to prepare for a removal. I'm going to have to remove something from the table. I then look ahead and see, what do I have to remove? I have to remove 1 red chip. But with the current configuration of what I can see and work with, I cannot complete the instructions because I see no red chip. So I'm going to have to make an adjustment, which is really just cosmetic. The value of what is in the square, on the table, in the bag, whatever, doesn't change. It's still a value of 2. But visually I've now prepared to be able to remove 1 red chip. I will do that, and so my value has now changed to 3 positive chips. So whether you prefer the number line model, whether you prefer the chip model, or maybe be able to handle and understand both, this is a foundational system that we can build our number sense with. Yes, when the numbers get larger and things get more complicated, we do need to graduate from this. But if we make sure of each step as we build that progression, we will eventually be more than capable in our arithmetic and very confident at the same time. That's the end of this episode. Join us next time for our continuation into foundational elementary arithmetic. Until then, welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe.